Question 6, and we're going to do what we did for question 5, and that is, let's run through the questions and see how we're going to answer them all, and then we can go into the nitty-gritty and the algebra of answering them. Okay, so we got g of x equals ax plus q. G of x is this straight line, and f of x is minus x plus 2 all squared plus 4. So that's the parabola, the negative, remember, indicating that it's a sad parabola fitting in. Okay, write down the chord. In fact, before we get to that, what form is this parabola's equation in? Is it in kind of just standard form, or is it in turning point form? That it is. Okay, write down the coordinates of r, this point here, the turning point of the parabola. Well, the turning point is just PQ. It's in turning point form, easy, gifted us to us. So the Q value is 4. Now, is this value going to be 2 or is it negative 2? Well, luckily we've got the picture here, so we can actually just see, does it look like a positive or a negative 2? Well, it must be a negative 2. And remember, it's x minus p. So this is the same almost as going x minus minus 2 all squared. Okay, calculate the length. Okay, so that's what r is. I'm just going to leave it in the diagram. Calculate the length of AB. Now, one way to do this would be to say, what are A and B? What's special about them on the parabola? Well, they're the x-intercepts, right? So y equals 0, y equals 0. Therefore, we can make y equal to 0, get a whole quadratic and solve it. And it wouldn't be too bad, because this, when we simplified it, would give you minus x squared, and that would be minus 4x, and we'd solve that, and it's not too bad. But I really want us to get thinking a little bit more conceptually and say, well, if that's a line straight down from the turning point, this x value must be negative 2. And our parabola is most certainly symmetrical about this line here. So if this is negative 2, in other words, if this distance is 2, then this distance over here must also be 2. That bit's 2, that bit's 2. So that whole distance there must be 4. Or going from negative 2, we need to go another 2, and we can get that. That must have been negative 4. This we knew was 0, 0. You can see it's going through the origin, and that would be our answer. As I said, solving the quadratic would really not be too bad, because you would have gone multiply by negative plus 4x equals 0, common factor x plus 4 equals 0, x equals 0, that's that one, or x equals negative 4. So the quadratic wouldn't have been too bad to solve this time, but look, this really is quite nice and quick to just go, well, that's 2, that must be 2, that's minus 2, that's minus 4. Okay, sense of accomplishment. Determine the equation defining g. Well, g is our straight line. What do we know about this value here of g? How much have we moved the straight line up or down? We haven't at all. It's going through the origin. The y-intercept is 0, 0. So q equals 0. So we know that for g of x is just ax. I'm going to call it mx, because we're used to things like that, right? M for gradient. How do we work out the gradient? Well, gradients just rise over run. So m equals rise over run. I'm going to zoom in. It's quite nice to just fit this all in right here by the diagram. So remember I was to go with run first. So how far are we running to get from negative 2 up to 0? Are we running by 2? How far are we rising to get from 4 down to 0? Or are we going by minus 4? So that's minus 2. So g of x just equals minus 2x. Always worthwhile thinking. It's a negative gradient, so we must have got a negative answer there. And we did. So just if we got 2, we could pause and go, hang on a second, that doesn't fit. We know that it's going down, so it must be a negative gradient. Just like this parabola's a side parabola, so it must have a negative in front. Okay, so upwards, onwards. For which values of x is g of x greater than f of x? I'm sure some of you are just coming in for maybe just this question. When is g of x, when is the straight line, when is it greater than, when is it above f of x. So let's go from left to right and just see. Here the parabola is below the straight line's above. That's what this is saying. The straight line is above the parabola, so this is good. I'm just going to highlight the straight line part of it. Okay, then for this next section here, the straight line is below the parabola. So this isn't true. We want to see when the straight line is above, it's greater than the parabola. So let's keep going from A. What about this section? Is this part above the parabola? It most certainly is above it. So we're looking at left of this. Well, we know what that is. We want to go, I'm just going to write it here kind of non-mathematically to go, well, left of minus 2. And we also want to look when it's right of, what is this point? The x value, 0. So let's make that look a bit more mathsy and say, well, x is less than minus 2. Strictly less than, because it's when the straight line's definitely above, not above or equal to. Or x is greater than 0. And there it is. Now it's a mathsy. Cool. E. Give the equation of the axis of symmetry of y equals h of x if h of x equals f of minus x. So if we're taking minus x, what are we doing there? Well, instead of having a positive x, what we're going to have is a negative x. So instead of a positive, we're going to have a negative, and I'm doing it on the x value. So I'm saying instead of a positive x, we're having a negative x. So in other words, we are going to reflect our graph about the y-axis, because the x's are changing. So f of minus x means that this graph is going to look the same, except it's going to be on this side. Okay, and says give the equation of the axis of symmetry. So in other words, if we drew a dotted line down here, what would that be? Well, here's the axis of symmetry of this graph at x equals minus 2. So what's the axis of symmetry over here? If it's just been reflected, so it's gone from the negative and reflected to the positive, well, this is just x equals 2. So that is x equals 2. Give the range of p if p of x equals minus f of x. So in this one, what we asked is really, what does this graph look like? So in the previous question in E, what we did was we reflected it about the y-axis, because it was the x's we were changing. In this one, we're saying take f of x and make it negative. So we're reflecting. It's like A. So A is negative, it becomes sad. If it's negative, it becomes happy, it becomes positive. So we're just doing a reflection to say, well, this graph is going to look, well, it's just going to reflect, so that's going to look like that and go through the origin. So there's what P is going to look like. Let's actually label it P of x, bit of putting, P is the turning point. And what is it asking for? The range. So the range relates to the y values. So this point here, the y values of all the ones that are kind of upwards of that point. Well, how are we going to work out what that point is? Well, we've got this point up here, minus 2, 4. So this bit's directly below. So the x must be the same. And the y is just reflected. So instead of positive 4, it's negative 4. So therefore our range is just y is an element of, well, it's going from there up. So the lowest point is minus 4, highest point up to infinity, which we can never get to. Okay, last bit. Give the equation defining the function of t if t of x equals f of x minus 1 plus 3. Let's do this just first conception. So what does this mean? So instead of f of x, we're going x minus 1. So we're moving the graph which way? Remember, the x1 does like kind of the opposite to what you think. So it was minus 1, so it's moving it right by 1. So it's like we've taken this graph and moved it right by 1, and we moved it up by 3. So we could look at it that way and say, well, if f of x is that the new graph is going to be, what did they call it, t of x equals, it's still, let's say parabola is still negative. instead of x plus 2, we've moved it right by 1, so it's not going to be as far left, it's only going to be x plus 1. And instead of adding 4, we're going to add in another 3, so it's going to be plus 7. If, however, that feels like a bit much, we can just plug this into our equation. So we're given that f of x equals minus x plus 2 squared plus 4. And we can just substitute that in. So we could say, well, f of x minus 1 plus 3. So whenever we see an x, we're going to replace it with an x minus 1, and then we're going to add 3 right at the end. So minus, wherever I see an x, I'm replacing it with x minus 1. So instead of x, I'm writing x minus 1. And I've still got that plus 2. Still squaring it. Plus 4, that's that plus 4. And then right at the end, let's add 3. Okay? So equals, let's just simplify the bracket, minus 1 plus 2, x plus 1 squared plus 4 plus 3 plus 7, and we are good to go. So if you want to, just substitute that into your function. Ideally, try and see what this is doing and go, well, it's moving it right by 1 and up by 3. Both get you there. Home dry.